Hello and welcome to this video tutorial for strings within the Lua programming language. I'm going to use a immediate window just to demonstrate some of the functions as we go through. Strings are one of the base data types within Lua. You can assign string with a conventional quotes, either double quotes or single quotes can be used to encapsulate a string. Lua also provides multi-line strings, so you can define a string and it will then preserve the white space and line feeds that were inherent when it was initialized. Within Lua, variable names are case sensitive, so you have to be slightly careful not to have typos, because if you mistype a variable, it will not necessarily generate any warnings or errors. So I've initialized a variable that's got a capitalized S and mistyped it when I've used it within the print statement. However, when I run that, it generates no errors or warnings, and when Lua encounters an undeclared variable, it will simply initialize it to nil. So here it gets to the misspelt variable name and simply initializes it to nil and prints out nil. So you have to be slightly careful with typing and aware of capitalization. Within Lua, variables are global unless defined with local scope. So you also have to be aware in Lua, functions can return multiple values. So for example, this expression is quite valid, and you can have multiple values being returned and assigned to multiple variables, all in the same expression. Lua does enable control characters to be embedded within strings. So for example, a string can use backslash to denote a control character, \n is line feed, backslash or double backslash will generate itself a backslash. You can have single quotes, double quotes, square brackets, tab characters and various other control characters which are embedded using escape characters. Lua will automatically convert some data values into a string where that's necessary. So for example, if I'm doing a string concatenation and one of the parameters is a numeric, it will convert it to a string for the concatenation. And there's a toString function. So for example, if I'm doing an equivalence test and I need to convert a string, I can do so with tostring, and it will then convert it as required. So if I run that, Lua has a number of ways in which it can concatenate strings. So if I clear the output window, you can concatenate a string using the concatenation operator, which is ... and you can, using that, convert or concatenate several strings. However, you need to be aware that each of the concatenation operators will generate a temporary memory-based string for the result of that concatenation. So that expression will involve creating 4 temporary strings in memory. So if you're handling very large strings, there are memory and performance considerations associated with the concatenation. So if I just switch over to the immediate panel, you can use string format to concatenate strings as well. So string format works by having a formatting string and a set of parameters that are then formatted according to the formatting string. So %s denotes a string output, so I take each of the parameters, apply it to the formatting string, it generates the output. One advantage of this is that you can provide separating text or encapsulating text within the formatting string, so it can be quite a powerful and useful way of concatenating strings. So you can also format non-string values as required. So string format is one way to concatenate strings. The third way is to use table concatenation. So I can use table concat and then a table. I'll deal with tables specifically within a further tutorial at some stage, but for now, table concat, the first parameter is a table variable. Then you can have a separator that is used to separate each of the values in the output string, and provided each of the values within the table can be coerced into a string, the function will generate a single string output that contains each value within the table, converted to a string and then separated with the separator string. You can also specify an index where to start the concatenation, and you can specify both the start index and the end index. So if I add a few more values to the table, it will in this case start the concatenation at index 3 and finish at index 5. You have to remember that indexes in Lua start at 1, so the first character of a string is at index 1 and the first character of a table is at index 1. Lua has a string library with a range of functions that I want to quickly run through. So if I define a string, I can determine the length of that string using the length function, or the more common format is just to use hash. Both of those will generate the length of the string. You can also get the numeric code for each character, so the byte code for it. By default, if you just specify the string, you will get the numeric code for the first character within the string. If you specify a index, you will get the character at that position. So if I say at index 5, I will get the character code at index 5. Note that all indexes start at 1 within Lua, so the first character of a string is at index 1, and similarly the first value in a table is at index 1. I can also specify a third parameter for the byte function, so I can say from 5 to 9, and I will then get the numeric codes for all of the characters from and including the 5th index to the 9th. There is the complement to byte, which is the char function. So if I just copy and paste those back in to save a bit of time. So char will produce the characters for each of the character codes specified. So there you can either go from code to character or character to code. Another point to remember is indexes can also be negative, so a positive index is from the first character of a string, a negative index is from the last character, so -3 is the third character from the end, or I could say from index -3 to index -1, which is the last 3 characters of the string. Lua also has functions to convert to lowercase, uppercase, or to reverse a string. So if I define a string S with both uppercase and lowercase characters, then .lower will convert the string to lowercase, upper will convert it to uppercase, and reverse will reverse a string. If I put the prints in the same, they'll all come out on the same line, so just to separate them, you can see the effects of lower, upper and reverse. There's also a function to repeat a string a defined number of times. So if I specify a string that I wanted repeating a number, which is the number of repetitions, then Lua will repeat that string the defined number of times. Finally, in this part of the video, I want to just cover the substring function. So string sub and I can specify an index where I want to extract a substring. Again, indexes can be negative, so for example if I say -4, I will then get the last word of this string. So I can specify I can specify 1, and that will actually produce the whole string. I can also specify the start and end indexes, in which case it's just extracting the first word, letters from the first index to the 4th index. So next I want to cover the find and match functions. They both have fairly similar syntax. So find has a input string, you have a pattern, and you can specify the index where to start the pattern matching the string search, and then a Boolean value which indicates whether the pattern is plain text or can contain what are termed magic characters. So I can do string find, my input string and my pattern, and that will return the start index and end index of the match. If I just try to find he as in the, I'm not specifying the whole word because here it's got a capital T, here it doesn't, then by default that will generate 2, 3, indicating the second and third character positions. I can then specify where to start the search, so I can look for the next instance of that, and then it will generate a match for the second the. Match is similar, except match will actually return the matching portion of the string. So Lua allows some special magic characters within pattern strings. So for example, I can use %a to mean any letter and then have a plus modifier meaning one or more. So this %a plus will match any word in the string that has one or more letters to it, and then a start index. So if I start at the beginning, then I will match to the. If I increase that to 5, I'll match quick, index 10, and I'll match brown. So you can use characters to then search the string, but Lua does not have full regular expressions to keep the core code size down for Lua and to provide the performance. It doesn't have full regular expressions, so it does enable you to have a dot means all characters, %a means letters, %c control characters, %d digits, %l lowercase, %p punctuation, %s space characters, %u uppercase, %w alphanumeric, %x hex characters, and %z is for byte 0. So if I modify the string to have a couple of numeric digits, if I change this to %d, and I'll take out the index, if I run that, it will match to the 10. So %d plus will find one or more numeric digits and match to that. So you can also have the complement, so %a matches to any letter characters, but %A matches to anything except letter characters, so it's effectively the complement. Also, you can use the caret symbol to indicate the start of the string and $ to indicate the end of the string. Your modifiers are, so if I have %a meaning letters, you can have the plus modifier meaning one or more, so one or more of whatever was prior to that, or the star character to mean 0 or more, or the minus character to mean as few as possible, or you can have question mark meaning 0 or 1. So for example, a pattern that is apples question mark will match either apple or apples. The character prior to the question mark, it can have 0 or 1 of those characters, so it will match both apple and apples. So if you want to match with, say, a numeric value, where a numeric value could be plus 100, minus 123, or just a straight number, then there you can define a custom character class. So a custom character class is defined with square brackets, so I can have a custom class with minus and plus in it, and then specify the question mark modifier, so it will say 0 or 1 of those characters. And then if I do %d, meaning a number, numeric digit, and plus, meaning 1 or more of those, then that will match to all of those values. So if I just give a few more examples of this to help explain how it all works, I use string.match with my input string, and if I want to match a word beginning in F, so I can use F itself, then %a to mean any letter, and the plus modifier to mean 1 or more of those. That will match fox, i.e. a word beginning with F, then 1 or more other letters, and if I just print that, it will match fox. Similarly, if I change the F for a D, it will match dog at the end. What I can also do is define my own custom character class within Lua. How I do that is by having square brackets and then the characters I want to match. So if I put FLD in there, and after the character class have %a and plus again, it will then match one of those characters, one of F, L or D, so either fox, lazy or dog, because it will take one of the characters FLD and then 1 or more other letters. So if I just run that as it stands, it will return fox. If I just copy this for a second and add a copy here and change it to find, just so that I can see the indexes at which it finds each of the words. If I then change the start index to be 20, it will then find the next word that matches, which is lazy, so it matches one of FL or D, i.e. L, and has 1 or more other letters after it. I can then change the start index to 44 if I want, and it will match dog. What I can also do is I can do a capture, so where if I take out these indexes for a second, I've noticed an interesting thing that isn't in the Lua documentation that I've seen. A capture is if I put round brackets around the match that I'm looking for, the pattern that I'm looking for, Lua will capture the text that matches what is in the round brackets. So in both of these, it's looking for the word beginning with F, L or D, and I've put all of that pattern within round brackets, which defines the capture. If I clear the output panel and run it, the find actually returns both the start and end index of the match that it found, but also returns the matching text. Match just returns the matching text. So carrying on with this example, if I just copy this match a second, what I can do is also have a capture here which is a word starting in F. Then I can have dot, meaning any character at all, and say 0 or more of those, and then specify a second capture, so encapsulate another pattern within round brackets. So here I'll say a word beginning in D. I forgot the plus, so there. And there I'm matching fox and dog, and the match is capturing the two words that were specified within the round brackets. It's ignoring the intervening bit. So just explaining this a bit further and explaining the minus modifier. So if I have my string match with my input string, and if I have a pattern that is a space followed by any character at all and 0 or more of any character, followed by a second space, so that has to basically match anything that is between two spaces. So if I run that, it will match the first space here and the last space. The star operator and the plus operator will match as many characters as possible in between. Now if I do exactly the same but with the minus operator, it will match as few characters as possible with the minus modifier. So here it's only matching the quick, it's finding this space, it then tries to match as few characters as possible until it finds another space in order to specify to comply with the pattern. Now with the minus modifier, you've therefore got to effectively anchor it at both ends, so you need something that it can sort of match to, otherwise you'll just end up with a null string. So if I move on to the gmatch and the global substitution function gsub, I'll carry on explaining patterns as well in the context of those functions. So gsub, global substitution, you have an input string, a pattern string, a replacement function, and the fourth parameter is a number representing the maximum number of substitutions to make. So if I have string gsub, my input string, I can, for example, create a custom character class. So if I say in square brackets AEIOU, that will mean any one of those letters, and my replacement function can just be a star, so it will replace any of those characters in my character class with a star, and it tells me that it's made 12 substitutions. You could also have what are called captures. So if I have my input string, and then if I say a capture is defined by round brackets, so if I open round brackets and say a word starting in F, so F %A for any letter, and then plus for one or more of those letters, and then I want it separated by any characters and any number of them. And then my second capture is a word beginning in D. So that's my pattern. So my pattern, just to recap, contains two captures. Each capture is contained in round brackets. My first capture is F, %A, meaning any letter, and then the plus modifier, meaning one or more of them. So that's a word starting with F and having one or more other letters. And my second capture is a word starting in D, then having one or more other letters. And for those two matches, those two patterns, to be separated by 0 or more of any other letter, which includes white space. Now the captures means that my replacement function, I can use % and then a number. So %2 means whatever is captured by the second capture. So in this case this. And %1 will be whatever is captured by my first capture, meaning the first set of round brackets. So if that's my replacement function and I run it, the initial part of the string doesn't match, so that's left untouched, but then dog and fox are reversed because I went %2, %1, and the intervening text is removed. If I put a space between them and rerun it, then they'll have the space between. Now what I can also do is specify a third capture and put this intervening text also in round brackets. And if I do %3, %2, %1, meaning the third capture followed by the second capture followed by the first capture, what that will do is just switch dog and fox around. So let me get rid of this to avoid any possible confusion. So there I've got the quick brown dog jumped over the lazy fox, and it's done one substitution because this was my overall pattern, so it matched essentially all of that, but fox was the first part of the capture, it was the first part of the pattern and was captured by the round brackets. The second part of the pattern, the second capture, is everything in between fox and dog, and then my third capture is dog, and then I reversed the order of those, so it went dog, the intervening text, and fox, which I've just changed the order again, but put that back. So hopefully that makes sense. So now what I can do is, if I actually go back a step and simplify this so that it captures just a single word, so there's no defined start character to the word, it's just any number of letters, and I want to remove the replacement function. Now what Lua allows you to do is actually put a function in here. So I can say function with a parameter, and I can say return x, so string upper x end. So what I've done there is I've got a pattern that is just matching to a word. Then in the replacement part of the global substitution function, I've defined an inline function, and whenever this captures a matched string, substring within the input string, it will pass that to this function through the parameter, in this case x, and all I'm doing is returning it back converted to uppercase. So if I clear the output and run that, I've now got everything converted to uppercase, and it tells me that it's performed 9 substitutions, i.e. there's 9 words, 1, 2, 3, 4, 5, 6, 7, 8, 9, just in case I doubted myself. Now what you can do within Lua is functions are actually one of the base data types. So you have numbers, functions, numbers, strings, booleans, nil, but functions are one of the data types. So I can assign a function to a variable just like any other value. And so now instead of putting the function within the gsub function, I can just have it as a variable, and that will do exactly the same. Now I can play around with this. So for example, just to show you that it is actually matching all of the individual words and converting them individually to uppercase, within my function I can put print x, i.e. print the captured text. If I assign this to a variable, so and print the result is. So if I run that, clear the output and run it, you can see it's actually printed out each of the words individually as it's scanned through the input string and captured using this pattern and the capture that contains, and each time it passes a matched string to the function is printing it out, which is why I'm getting each word printed out. It then converts it to uppercase, returns that, and whatever is returned by this function is substituted back into the string. And so I get an output string which is all uppercase. Now I can further play around with this a little bit. The advantage of putting it into a variable is I could do something else here. So I could say e equals and another function. So I'll think about that in a minute, but I can basically use the same function but with a different so in this I could just use my character class to match fox, lazy and dog, and %a plus end my capture, and if I print another line, the second function returned so clear that and run it. So here I'm getting this. So these just to explain, I've got the quick brown fox jumped over the lazy dog once, which was the first time this ran, but for the second function it only matched with fox, lazy and dog. So actually if I just for ease, if I just comment out this for a second, so we're only dealing with one, so you can see this only matched fox, lazy and dog, and it only capitalized those 3 words. I could further extend this. So for example, if I say if x equals dog, then return nil, else return the uppercase version. Now what that's doing is it will only be called 3 times for fox, lazy, dog. When it's dog, it will return a nil value. Now what that does is if the replacement function returns nil, then the global substitution basically leaves the text unchanged. So nil is basically the same as substituting back the source matched text. So here I've then just capitalized fox and lazy. So hopefully that makes sense and illustrates the sort of power and versatility of this, even though it hasn't got full regular expressions. You can actually write whatever code you want in this replacement function. It can do whatever you like there. Whatever it returns will be substituted back into the string in substitution for the matched text. So moving on to the gmatch function. Gmatch is slightly different, and if I just put a comment in, so you have gmatch, your input string, and then a pattern. And what gmatch can do is it provides an iterator basically. So if I have a for loop, so if I say for w in and then a string.gmatch, I have an input string, and if I match words and then print them, basically this will iterate over this string matching with this pattern. So if I run that and I will get rid of, I'll just comment it out for the time being, just in case I want to come back to any of it. So it will basically pass that, and this pattern is just matching with words, but again you can put whatever code you like within this loop, but gmatch basically provides an iterator that will pass through your input string, matching it to your pattern. And again, you can have the modifiers, the magic characters, your own character classes, do whatever within that pattern. So I think that's about it for strings, at least as an overview. I hope you found this useful. If you've got any questions, please leave a comment and I'll try to deal with any questions. It might take me a couple of days or a few days to get back to you. I'd appreciate any comments within the comments below, and I hope you found this video useful. Thank you for watching.